This video has more practice problems converting. We will convert from grams to moles and moles to grams. Before we work on conquering converting from grams to moles or moles to grams, I want to review how to calculate molar mass of a compound because we're going to need this calculation and the relationship to be able to do these conversions. So here's the formula for magnesium hydroxide. So let's calculate the molar mass, and to do that we need our periodic table because you're going to need to look up the masses on each symbol. All right, so let's look at magnesium first. So if you look at magnesium, it's over here, number 12. It has a mass of 24.305. So I'm going to use the mass of 24.31. So magnesium, coming from the periodic table, has a mass of 24.31 grams. Now there's only one magnesium, so I'm only going to have to count that one time. Our next element is oxygen. We have 2 oxygen. Oxygen is in the parentheses and there's a 2 on the outside. So I'm going to put 2 in parentheses here because whatever number I pull from the periodic table, I know that I'm going to multiply it by 2. So if we look at oxygen, its number is 15.999, so I'm going to use 15.99. And make sure you have your own calculator so you can do these problems with me to make sure you understand how to do them. So I'm going to take 2, I'm going to multiply it by 15.99, and I get 31.98. Okay, and so our last element is hydrogen. So for hydrogen, I have 2 of them, so I'm going to put 2 in parentheses, and the mass for hydrogen is 1.008. So I'm going to use 1.01. When you multiply 2 by 1.01, you will get 2.02. Okay, so at this time, we need to add all the masses together. So we have 24.31 plus 31.98 plus 2.02. So do this on your calculator just as I do it. 24.31 plus 31.98 plus 2.02, and the answer is 58.31 grams. And that is the molar mass for magnesium hydroxide. Now what this also tells us, and this is the relationship we're going to need to do these conversion problems. This tells us that 1 mole of magnesium hydroxide equals 58.31 grams. So now we have a relationship. This relationship we can use to convert from moles to grams or from gram to moles. Okay, so we're going to go ahead and use magnesium hydroxide. We've already calculated the molar mass to be 58.31 grams per mole. So I know that, so let's go ahead and make up a problem and convert from moles to grams. So I am given 3.56 mole of magnesium hydroxide. This is what I'm starting with right here. And I need to convert that to grams. So take the number that they've given you, 3.56 moles, and that's how we start our problem. Let the unit tell you how to set up your conversion factor. So our conversion factor is coming from this relationship right here. 1 mole equals 58.31 grams. So use this unit mole to tell us what to write down here on the right. and then grams is going to go on top. Then go up to our relationship. You have 1 next to mole, so we're going to put that there. And next to the G, you have 58.31. Your moles cancels out, and we're left in grams, which is what we need. So you can go ahead and write that unit there. And then you get your calculator, and you have 3.56 times 58.31. And you will get 207.5836. So we need to watch our significant figures. We can keep 3 significant figures. So I'm going to say 208 grams. Circle our answer, and that's it. It's just a one-step conversion. Now, I had done some work beforehand. We had already calculated the molar mass. I set up the t-chart, and so a lot was already set up with this problem. Our next problem, we're going to do it all from the beginning in one shot. Okay, so let's get started. We need to convert 2.6 moles of sodium phosphate to grams. So we're going from mole to gram. So we can set our t-chart up, and this kind of tells us what we're going to do. We're going to start with 2.6 moles, and that number we get from our problem. So that tells us right away that mole is going to go on the bottom, grams is going to go on the top. But we need the numbers that go there. Well, we need to know the molar mass of sodium phosphate. So this is where we kind of become experts at calculating molar mass because we have to do it so many times. So let's calculate the molar mass of sodium phosphate. So for sodium, I have 2 atoms of sodium in this compound. Now I use the periodic table. I need to look up sodium, and it is 22.99. So 22.99, we'll multiply those two. Let's go ahead and do that. 2 times 22.99 is 45.98. Okay, so that's for sodium. And then I have phosphorus. Now I only have 1 atom of phosphorus, so we just go to the periodic table and we pull up phosphorus is 30.97. So we'll put 30.97 grams, and that's phosphorus. And then we have oxygen. Now oxygen, we have 4 of them. So we're going to take 4 times oxygen's molar mass, which is 15.99. Now some of these elements we use a lot, and so you will get to know them, and you will not have to look every single one up. All right, so 15.99 times 4 is 63.96. Okay, so we have our 3 elements and their masses, 45.98, 30.97, and 63.96. So we're going to add all those together. 63.96 plus 30.97 plus 45.98, and you get a total molar mass of 140.91 grams. Okay, so that gives us our relationship. Now we know that 1 mole of sodium phosphate, remember what we just calculated, who we just calculated, equals 140.91 grams. All right, now we have our numbers. The 1 goes next to mole, and the 140.91 goes next to the gram. Now we look at what units gets canceled out. Our moles gets canceled out, and then we have 2.6 times 140.91, and you get 366.366. And the unit is going to be grams, but we need to watch our significant figure. So we started with 2.6, so we can only have two significant figures, so we're going to round this to 370 grams. And that's our answer. So 2.6 moles of sodium phosphate equals 370 grams of sodium phosphate. In this problem, we're going to convert from grams to moles. So we're kind of flipping what we're doing. So basically, we're just flipping the conversion factor another way, but we still have to calculate the molar mass. So let's get started on this one. We've got 23.32 grams of potassium carbonate. So let's draw our T-chart and get started with that. So if we have our T-chart down here, we are going to write 23.32 grams to get started. And then we take the grams, let the unit tell us what to do, and we're going to put it down there, which means the mole is going to go up there, which is what we're doing. We're going from grams to moles, so grams to moles. All right, so now we need to calculate the molar mass of potassium carbonate. So let's do that. So we have potassium, and we have two of them. And we need to pull the periodic table up and see what the mass of potassium is. And that is 39.09 is what I'm going to use. So 39.09. And you multiply that by 2, 39.09 times 2. And make sure you're doing these problems with me. 78.18, so you can see where I'm getting all these numbers. And then we have carbon. We only have one of carbon. So when we look at carbon on the periodic table, carbon is 12.01. So we put 12.01. And that's it because there's only one. And then we have oxygen, and we have 3 oxygens. And I know that oxygen is 15.99. We've used it in the other example, so it's kind of fresh in my mind. But if you need to, look on the periodic table to see where I got the 15.99. All right, so we take 15.99. We're going to multiply that by 3, and we get 47.97 grams. Okay, now we have all of our masses for the 3 elements, potassium, carbon, and oxygen. We have 78.18, 12.01, 47.97, and we need to add those 3 together. So 47.97 plus 12.01 plus 78.18, and you get a total of 138.16 grams. Okay, so now we have our relationship, and we can plug in our numbers and finish the problem. So what we just calculated is that in 1 mole of potassium carbonate, we have 138.16 grams. All right, so let's look at how many grams we have. We have 23.32. So just kind of looking at these two numbers right here, the 138.16 and the 23.32, I know I do not have 1 mole. It's going to be less than 1. So this kind of helps you know if your answer is correct. If your answer comes out more than 1, then we probably didn't set it up correctly, or we entered it in the calculator wrong. If it's less than 1, then we probably have the right answer. So let's plug our numbers in. We're going to have 1 on top, and then the 138.16 grams on the bottom. Our grams will cancel out. And now we do the calculation. You have 23.32, and you're going to multiply that by 1. Now you don't actually have to do that because it's the same number, but just kind of showing you what the process is. And then we're going to divide it by everything underneath. So we divide it by 138.16, and we get 0.168789, and it goes on. All right, so we need to look at what unit we're going to end up with, and the unit that we're in is mole. So let's see how many figures we can keep. We have 4 significant figures in our number, 23.32. So I'm going to keep 4 significant figures. So that's 0.168. The next number is 7 with an 8 next to it, so I'll round it up to 8 moles. So we just converted from grams to moles. So what we're saying is, if I had 23.32 grams of potassium carbonate, it would equal 0.1688 moles. Let's do one more problem. In this problem, we're just going to have an element. So it's not a compound, so it's just one element. So actually, this is probably the easiest of all of them that we've done in this video. All right, so the problem here is 52.3 grams of silicon to moles. So we are converting from grams to mole. All right, so we set our T-chart up. And you take what they gave you and put it in the upper left-hand corner, 52.3 grams. Let the unit tell you what to do, and what to put down in the lower right corner would be grams, because we want these units to cancel out. So therefore, mole would go on the top. All right, so we have 52.3 grams, and we're converting it to moles. So the grams cancels out. We can already see that. All right, so we need the numbers that go here. So I need the molar mass of silicon. So 1 mole of silicon, and we just look at our periodic table. You bring that up. Silicon is 28.09. Let's use that. 28.09 grams. All right, so now we know where to put our numbers. So we put the 1 next to the mole and the 28.09 next to the G. All right, so now we get our calculators and we solve the problem. So we have 52.3 times 1, which is itself 52.3, and then divide it by 28.09, and we get 1.861. So I want to check my significant figures. So 52.3 has 3 significant figures, so my answer can just have 3. So it's going to be 1.86 moles. So let's see if this makes sense. All right, I had 52.3 grams of silicon. How many moles is that? Well, 1 mole of silicon is 28.09, okay? Let's see what 2 moles of that is. So 28.09 times 2. 2 moles of silicon is 56.18. All right, I have 52.3, so I have 1.86 moles. Yes, it does make sense. It's not going to be exactly 2 moles, because 2 moles is 56.18. So you really don't even have to check with a key or anything, because we can look and just see that it makes sense. If 1 mole is 28.09 and 2 moles is 56.18, then 1.86 moles being 52.3 grams makes sense. And that's how you can kind of check yourself to see if you're getting this correct.